Well, hi, good morning. Thank you so much for joining me in my shop here on April 6th. So I wasn't in my shop yesterday. I took the day off yesterday. But I'm back in here today. And the conclusion I've reached with this radio at this point is the weak element is the antenna. Now I got fooled here by just opening up the radio and finding this antenna in it. And thinking, well, one, this is the right antenna, but then later thinking, no, this is an antenna somebody has added because the correct antenna is missing. And I've looked a number of times for evidence that there was an antenna on here, a loop type antenna, and some glue spots and stuff, and I kind of carried on with the idea that there was a loop antenna involved with this radio. Yesterday I did a little studying up. This is why I wasn't in my shop here, to kind of refresh my memory on antennas, loop antennas. I looked at many radio schematics and finally took a look at this one. And thank you, I think it's John, who sent me a much better copy of the schematic here. This one's much neater and also contains the component values written right on the schematic. So we're going to use this, and we're going to discover very quickly tain't no loop antenna associated with this radio. So when we look in here, we see this coil, which could be mistaken for an antenna, or could be an antenna, and we have this coil down here. Let's find these coils in the radio. So the first one to find is the oscillator coil. It's got 1, 2, 3 leads out of it, and there is a capacitor, a picofarad capacitor connected to it. So this coil has this capacitor connected to it, 50 picofarad. Well, you know what? This coil also could have a 50 picofarad capacitor hooked up to it. Okay. This 50 picofarad capacitor hooks up to a 20K resistor. This one heads out on the antenna, so it should be easy to tell the difference. This coil has 3 leads coming off it. This one only has 2. Where are these coils? So one coil is down under the chassis in the radio, which you can't see right now, under here, and the other coil is up here. You can just get a hint of it. Let's start with looking at this coil. Make sure I don't have this plugged in. Right away we see the capacitor connected to it. And we can see one lead is grounded to the chassis here. Even has this ground wire sharing the pool of solder down here, and there's 2 other terminals up here. One has the capacitor and the other one has a wire coming off it. So there's our 3-terminal coil. The other coil, it's a little hard to see it here perhaps, is right here. This certainly appears to be a 2-lead coil. 2 leads here, 3 leads there. 3 leads on the oscillator, 2 leads on the other coil. So here's the other coil. Now what is that other coil doing in there? So if we take a closer look at the antenna arrangement, this is the coil in the radio. There is no coil or loop antenna shown on this diagram. Instead, there's just a pointer pointing straight up. Well, maybe they should have wrote antenna there or something, but I think we can be pretty sure that's heading to a wire antenna, ideally outside of the house where the radio is. And it's going right to the grid of the mixer tube, straight in. So what's this coil doing? So this coil is hooked up in parallel with the tuning capacitor and its trimmer. So there is a tuning taking place, or a resonance taking place here. It's a tank circuit. When it resonates, it's very, very high impedance. So that would show no load, if you like, on the antenna, and everything the antenna's got is heading to the grid. Other frequencies which do not match the resonant frequency of this would see these as a way to get to ground. And so the farther away you go from the tuned resonant point, the more and more power in the antenna just gets shunted to ground and lost. So this is the whole deal with this arrangement. You can think of it a little bit differently too. You could think of this as being like a bell that's going to ring, and all it's got to do is get hit by the right kind of hammer. Okay, you can hit a bell with almost any hammer, but you need to hit this with the right frequency. So incoming on the antenna are a pile of different frequencies. One of them matches the resonant frequency, and this thing will start ringing like crazy, and the result is the energy is, I don't want to say multiplied here, maximized might be the right word. Off it goes to the antenna. So there's a tuning effect here. So this is the front end tuning. It's completely independent of the antenna, except the antenna is hooked up here. So it would have a small bearing hooking up the antenna, but this is a small capacitor here. And why is there a capacitor here? Well, I don't know. It could be multiple reasons. Well, one reason could be for protection. This is a unpolarized plug here, and perhaps the chassis, I haven't really looked, the chassis goes live. If you plug this in the right way, yes it would. You can see right here, because this is not polarized. Live chassis. This is ultimately connected to the chassis, okay, through the capacitor here, but still connected to the chassis. 120 volts sitting here, 120 volts here, 120 volts out on the wire. There you are, hanging your antenna in the backyard, and it's the last thing you do. Put a little capacitor in here, and you restrict the current flow that could, the fault current or shock current that could flow. That could be part of the picture. Another one is, well, they're trying to feed DC to this grid through this path. Those clever radio engineers. So they're developing a DC voltage here in the detector, and they're using that DC voltage, it's arranged to be negative voltage, to stick onto the grid. But maybe if you didn't have this capacitor here, this antenna may go out. Who knows where it's going? Lay in a tree somewhere? I don't know. And so maybe it would bleed off some of the AVC voltage that's trying to make it there. So maybe that's what that's for. Or maybe it's some kind of impedance adjustment for the whole antenna. So you stick the wire out there, and the impedance of the wire is not as appropriate as it would be if there were a capacitor here. So that's another possibility. I don't really know what it's here for. I should have read up instead of going through all those ideas, but it's probably some combination of all that stuff. Okay, so what do we do with this antenna? So hooking up the loop antenna that came with the antenna, that came with the radio, is not going to get us very far. You could think of, well, first of all, if the way the loop was connected was here, then the loop, and the other wire was connected to here, to the chassis, right to the chassis. That's bad, because that is going to short out the AVC voltage from this first tube, I think. I think that's what's going to happen. So you're not going to really generate much in this coil anyway, this antenna. And you'd be hooking it kind of in parallel with this. So now the resonant, or the impedance of this, has now got this other coil. It's just wrong. Wow. So, well, that's the lesson here. You get a radio, you really got to question just about everything you come across that seems to be in any way not normal. So, not normal. So what do I do here? What do I do? Well, I think we should try to find this capacitor and find out if it's in the radio. And normally, commonly, these radios have a wire hanging out. In fact, very often they have two wires hanging out, a ground and an antenna. And quite often the antenna is kind of over here. Comes down, has a coil here, makes a transformer with this, and then goes to its own ground. It's never ever connected directly to the radio. But this one is connected directly. Another thing too would be, I'm not sure what to say about this, but I am not going to say anything. Okay, another thing. Lots of things. Other ideas in my head. Jim, just because you have ideas doesn't mean they're any good. Okay, no guarantees. My head is not a guarantee. What to do? So I think we need to play this radio the way it was intended. Hook up a wire antenna, just the way it was intended. Look for this capacitor or add one in. Abandon this antenna entirely. Just, it's gone. So the antenna should be connected, could be right to this terminal, like this antenna is. So hook this up here. Let's say goodbye to the loop antenna right now. Goodbye. Okay. Goodbye. Goodbye to the loop antenna. Well, it may come back. You never know. It may come back for another run. I sort of said to myself that whoever had worked on this radio before had a pretty good notion of what they were doing, so I shouldn't really doubt automatically something I see that looks anomalous. Maybe it's actually a stroke of genius on somebody's part, and I'm just not with it enough to recognize it for what it is. Okay, so the antenna connection, let's rotate it here. The antenna connection is probably here. There is a wire. That wire is running all the way to, you know what, there's the coil. So the wire is running, the wire runs all the way to the coil. So we're down in here. Now somehow it gets over to the grid. Well, it is the grid. It's right on the grid of this tube. It comes right over, the wire comes over, attaches to the grid, and this coil is attached to the grid. So the capacitor would lie beyond. So I'd have to get my own 50, stick it on here, 50 sticking out, and then we stick a wire antenna on. I've got something that will work as a wire antenna, I think. High impedance antenna is what we want. We don't, and it could be, my antenna may not be high impedance. Can we tell? Can we tell? I've never done this. This is the antenna lead. No, it isn't. That's the wrong thing. It was an antenna lead, wrong antenna. Okay, so this is the lead that goes to my outdoor antenna. But right now, I'm sure the outdoor antenna switch is off. So this is actually just a lead going through my house inside coax cable. Regular TV, 75 ohm coax cable. Going from here to the other side of my house. And then it's an open switch. It's kind of like a wire, isn't it? I was going to measure this. So this is really an open cable. Goodness knows how it will test on here. I've never done this before. I don't know what to expect. Sometimes it's better to look and then try to explain what you've seen than to try to guess what you're going to see. So we see a capacitor here, 2,000 picofarads, which is 2 nanofarads, which is 0.002. So this cable looks like a 0.02 capacitor. It's not very good. I don't think we want that in an antenna line. Now, I'm going to go through the switch and we will repeat this test and see what happens. Okay, so I've thrown the switch. Now there's much more cable, 50 ohm cable included. No, still 75 ohm cable running all the way out to the antenna from here. So I've doubled the coax and added a fairly substantial outdoor antenna. Now, a much better way of making tests on the end of this line would be to use one of these. This is a Nano VNA. I have 2 of these. These are great, except I'm having a very difficult time interpreting the results because they're very complex. So we're not even going to try that. That's another whole story to come. Now, what do we get this time? It's essentially the same. 0.002 microfarads. 0.002 microfarads. Yeah, I think it's probably, I've never done that test before, but I think it's probably indicating that the capacitance in the cable is going to suppress things. I don't know. Does that make sense? That may not even make sense. Okay, I'm going to put the capacitor on here, and this is suggesting a 50 picofarad. 50 picofarad. I'm not sure I have one quite that small ready to go. Let's see. It's got a resistor in it. 50 picofarad. This is 200. It's way too small. Clip lead. Okay, I'm going to get a 50. I'm going to solder it right on there, because I think it's going to be kind of a permanent thing anyway. Okay, I think I'm ready to power up the radio. Here we go. There goes the clock motor. So this is now my outdoor antenna. That goes out to a folded dipole antenna with a balun on it. I'm trying to remember now. With a balun on it. So, I believe it's a 1 to 4 balun I've got going. So, folded dipole, 300 ohms. So, a quarter 300 is around in the area of 75 ohms, which is in the area of the cable that I'm using. That's what's going on. Okay, you don't hear anything happening here. I'm doing pretty good as an antenna. Okay, that was full blast though. Let's turn it down. Look this up. Ooh, that's a lot. That's a good sign right there. Can we pick anything up? No. Okay. I'm not surprised. Now, what else can we do here? Redo the alignment. Now, the IF alignment should be fine, but fooling around here will almost certainly have had some effect on the antenna tuning anyway. Let's just do it. No big deal to try. If I remember right, I was tightening the capacitors right down on both the oscillator and this. Doesn't feel very tight. I got a big screwdriver this time. This is making zero difference. What's going on there? Do that. Don't do that. looking for ways to get a shot there. Well, I'm going to hook the ground up. This is not correct now, but let's try it anyway, because let's try it. Okay. Silences the radio, drops the impedance of the input to the first grid to almost nothing. You got to turn the radio right up. It's got nothing. Almost nothing. So this would be similar to having the loop antenna on there. Nothing happening. We need the high impedance. I think its reception is very, very weak. I'll do this all day. I'm not going to pick anything up. I got to think about this. Where am I going with this radio? What is left that I could possibly do to it? That could, yeah, exactly. We need that badly. I don't know. I don't know. Gotta go think. Well, I reached the point of trying crazy things, so let's try something crazy. Here's a transformer, probably an antenna transformer from a radio. I don't really know where this came from, actually. And it has two coils. There's two coils in here. It's a transformer, and they're not joined in any way. They're two completely separate coils. One connects here, and the other one connects on the other side. We're going to use this transformer to try isolating away the antenna from the radio and see what happens. And I just can't imagine this is going to work, because when I hook the other side of this up, I'm putting a low impedance across the grid input. So kind of dumb, but let's try it, because it's not unusual for me to get a result that I have no expectation of. Let's turn the radio on. Let it warm up. Now we're starting with my outdoor antenna here, but my real intention is to put the loop antenna on here. But again, I just don't see how it's going to. I don't see how this is going to work out. The way I have my loop antenna designed, it presents a very low impedance to the radio. And that's a big loop antenna behind me I'm talking about. Okay, Mr. Radio, you should be making some sound here. Okay. So this should essentially short out. No. That's good. Is that coming from here? No. Oh. So if the white one is ground and this is going into the radio, this is the transformer. Good luck. That's a long shot. Of course, it's not going to work. Okay, let's try the loop antenna now. And for all I know, I have that transformer, this transformer hooked up the wrong way. Got hooked up backwards. gonna make this radio work, champ. Let me just tune the loop antenna here. This is the wrong angle. No effect. There's no effect at all. I think this is a dumb idea, but let's not quit right away. Ooh, made quite a difference. This must be the low impedance side. That must be high impedance. This must be the secondary. Not going well. Okay, dumb idea. Dumb idea anyway. Just this piece of wire was doing that? Wow, this doesn't take much wire to come to life. Maybe I should just try a straight wire, piece of wire type antenna. Forget my my cabled antenna. Just let me make sure I got the right thing here. Okay, we're going back. We're going to the loop antenna. We're gonna connect it. We're gonna have to ground it and put on here. Pretty quiet. More quiet. She's a quiet one.
Father who was a professional athlete himself and coach and wants to impart advice to his kids, but also wants his kids to have fun and knows when to step back. How did you walk that line? Was it difficult for you?
Oh my. It just happens to be tuned? Yeah. Wow, lucky me. Now, I had this capacitor here. I didn't before the loop antenna. I went straight on.
Did you see the ball today?
It's even better.
Okay, and did you swing at good pitches? Okay, that's the first thing. Because if you get up and I'm not seeing rotation.
Oh my. Okay.
It doesn't matter letting all of them tell me what are you feeling. Because I'm not in the box, I'm not at the free throw line. I'm what are you feeling? And just tell me what you got. This is not so much emotion. It's like, this is what I got, this is what I'm doing. Okay, so then we can go ahead and start the process of going. So I think not dictating and having them tell you what do you see. I mean, there's tons of times Sophie goes, I just didn't pick it up. I said, I get it. I said, I totally get it. So we're not talking about anything mechanical. We're going to move on in the process and do those types of things. So it's a matter of creating the right. And my daughter Taylor, she's got no conscience. I don't know if she can miss the first 7 shots of the game. She goes, give me the damn ball. I'm going to shoot.
I was switching an auxiliary capacitor in and out there on the antenna. Well, okay, we got there. All you need is that great big loop antenna. So you put this guy back together in the clock, you put it on your wall, and you run a wire over to a big fat loop antenna like that in the middle of your kitchen. Fantastic. Of course you gotta aim it. Beautiful. I don't know what. What? Okay, now I'm also in a quandary. I'm going to get a piece of wire. I'm just going to put a piece of wire antenna on here and see what happens. A piece of wire antenna.
Playing catch up, that's not a good thing. It has to be always almost perfect. And right now for Chapman, it is perfect. How having stride separation means...
This is a piece of wire, just runs on the floor behind me for about 15 feet or so, 10 feet. Good. I'm going to go grab the end of the wire and move it around. Okay, didn't make a hill of beans worth the difference. So, now if this wire were hanging out the window in the air, well, it would be better. But would it ever compare to that loop antenna? No, I don't think it would. So, is this radio working as good as it works? Is the diagram I'm using incorrect and there really is a loop antenna connected to it? Can't see it. Everything in the radio matches this schematic, except the 50 was missing. That's kind of interesting in itself right there. Okay, gonna stop for a bit. Really got to think about where I'm at with this radio, where I'm going with it. I'm sure I'm close to the end of the road with it. Yeah. Okay, let's try this. Let's try to find out where the front end resonance is in this radio. So to do that, I've got this loop shoved in here. It's just shoved in. It's right near the coil that's being resonated by the capacitor, the antenna coil. And I've got that going to my SDR. I'll put the SDR on the screen in just a moment. And then what I'm going to do is I'm going to tune the radio back and forth. You're going to see the local oscillator very clearly. But what I'm going to look for is the front end tuning, which is a little harder to see in this case, but you can see it. If you look hard for it. Okay, so let's go and look at the SDR now. There it goes. Okay, so on my SDR, this is the local oscillator here. The front end tuning, right now we're tuned down at the low end of the band. So somewhere in here, there is some tuning response, a resonance response. And if I tune the radio up and down, you'll see this move back and forth, and you should see something moving back and forth here, but it's very subtle. So keep your eye down here. I'll start tuning it a little bit. Seeing it. Okay, I see it now. Right in this area. I'm going to turn down the radio. The way you can see these is not so much bump down here in the noise, but these signals, these are interference signals. They get boosted as the tuning goes by them. So watching that one right around 900 there. Now wait a minute. Okay, so there's two things. There's some weird stuff on here. Right around 650. Yeah, those are anomalies to be ignored. It's not what we're after. So I'm going to tune right down to the bottom of the band here. Now, I can't see it. I thought I could see it before. It should be right in here. There should be a little bit of a thing happening. Try it again. Where'd it go? Okay, so I think it's right around 640 right now. So what I'm doing is watch right here where the green line is. Right there, but I'm going to move the green line away. See that come up? That's the tuning peak going by. So we want it around 590. So the front end tuning peak, I think, is at 590, even though it's not having much effect. That's part of what I'm discovering. At least the way I'm trying to detect it. Although it certainly detects this. So if this is at 1068, what if it was at 1055, then the radio would be tuned to 600. But it's actually a little higher. So right now the radio is trying to receive up here. It's converting up here, but it's boosting down here. So I think there's clearly an alignment issue here. I got to get a better view of this peak, and I think I have a whole other approach I can get a look at it. Okay, so what I've done now is I've turned on my sweep generator here. This is sweeping from 5500, basically pretty much the bottom of the AM band. And it's only going up to 1328 because I can't get it to go any higher. So I'll turn the sweep on. If I turn the volume up on the radio now, is that all out of focus? Let me turn the volume up here. So that's the sound of the sweep going by. I can slow the sweep down. You'll hear it. Okay, but I've got it running pretty fast. So it sounds like a buzz. Going by the tune point in the radio repeatedly. Okay, let's take a look at the SDR result. I can turn the volume down here. We don't need to listen to it. Just enough to know it's there. Okay, let's go. Now, the pickup antenna has remained in the same place for the SDR. Here's a local oscillator, and now you can see quite clearly there is something happening here. Let me slow down the decay on this. We'll get a nice looking display out of it. So there's the tune point right there. So right now the front end is tuned to 571. A local oscillator. Let's do this. Let's set the local, let's force it to a nice even number here. 1055, because it's right in the neighborhood. 1055. So I'll put the red line on 1055. Now I'm going to tune the radio to move the local oscillator. I'm going to have to change the okay, let me just turn on the decay here for a moment. Swoosh. Turn it back. So we are just off by a hair, but that makes a difference doing this stuff. So let me just, wrong way. So I'm getting the local oscillator right on 1055. Now we subtract 455 from 1055, we get exactly 600. So I know the radio is trying to convert 600, but the front end is boosting 550. So let's adjust the front end until it's right here at 600. And I'm not going to let you see me do that. I'm going to be turning the trimmer screw on the front end tuning. Okay, here we go. Turning the screw. And it got a little bigger, I think, but it didn't go anywhere. Let me turn it down again. Turning the screw down. Whoops, screwdriver fell out. So I had the trimmer screw wide open there. Okay, back in with the screwdriver. Let's tighten it down. Hold on. Okay, it's pretty much as tight as I can get it there. Didn't go anywhere. Well, that's another interesting question. Why wouldn't that go anywhere? And here's another something I thought of last night. I just forgot about it until just now. So, what are the chances that the dirt in here is sufficient to affect the capacitance of that capacitor? There's a lot of dirt in there, and I've made no effort to remove it. Would this throw the radio off? I've never had one thrown off by something like that. I'm going to try to sweep the dirt out, and we'll watch the SDR, but I just can't imagine anything would happen, but let's watch it. Okay, so we really are interested again down around 600. I'm going to do that part of the capacitor here. I just can't imagine this would do anything at all. So what would dirt do in a capacitor anyway? Probably reduce its capacitance. Wouldn't that be the logical guess? Okay, I'm doing the local oscillator. You can see from the oscillator variations I've moved the capacitor because I'm brushing it with a brush. In fact, I'm going to move the capacitor way open. I'm just dusting it with a brush. Okay, I just can't imagine that did anything. Go back to roughly where we were. A local oscillator on the red line at 1055. There we are. And we're still listening in the wrong spot. Now my options here. I can force the local oscillator to match the front end tuning, since I can't seem to trim the front end tuning. What else could be going on here? What else could be going on? Don't know. Don't know if anything else could be going on. Seems like that's my only option. So I'm tightening the trimmer capacitor way up. It's not doing much. You know, I got a 50, actually it's a 40 picofarad capacitor sitting right here. Why don't I do this? I'm going to inject the signal not through the 40 pico, straight on to the here, like this. Okay, so I've cut the little capacitor out of the circuit, but now I'm going to ground that capacitor and see what happens. I'm going to try to ground it. There we go. Okay, so that's grounding it and releasing it, grounding it and releasing it. What happened to the front end resonance? Disappeared. Let me put the capacitor back in the circuit. Wow, that's interesting. That's pretty interesting. So when I hook my what am I hooking up here? The signal generator. Now the signal generator has like a 50 ohm output, so I'm on the far side of the capacitor. The radio is much happier. And if I put it straight on to the, if I bypass that capacitor, it knocks the resonance right out. Oh my gosh. Okay. So is this... Okay, so I said the signal generator had a 50 ohm output, but I don't have the ground connected from the signal generator. If I connect the ground, that's probably just, what's that going to do? It's either going to blast our ears off. It doesn't have much effect. Well, it has an effect kind of further down the line. All kinds of noise being ejected. What happened here? Let me put it back on. Yeah, just things I can't explain at all. What do we want to do? We want to try a variable capacitor in the position where I have this. Let me switch back to the cameras here. Let's try this. So this is a 40 picofarad. The schematic calls for a 50. 50 sounds pretty round to me, a pretty round number. I've been hooking this up here, and on the SDR we see the front end tuning. If I hook it up right onto the terminal here, there's no tuning in the front end. Is this capacitor big? If I made this even smaller, would we get a bigger and bigger effect? So I'm going to put a variable capacitor here, like a trimmer. I've got to figure that out. How am I going to do that? Okay, I have another radio here. This is never ever going to work. So, because I'm never going to make this radio work, I'm going to use this capacitor to put in place of the fixed one here, and then we'll be able to tune this all the way from pretty much 0 up to 350 or whatever it is. Quite a bit. So we'll be able to find out if variations matter. Now we don't want this hooked up to itself anymore. I want to get this on. Okay, so cutting this wire makes the stators here completely isolated from everything. So what we would want to do is, say, bring the signal from the signal generator. And I'm going to leave the ground out of the picture for now. I'm going to hook that there. It's kind of weird leaving the ground out, but I don't know what else to do. Now the output, or the other side of this capacitor, is the chassis. Big honking chunk of metal here. I'm going to put a clip lead onto the chassis, and the clip lead is going to go to the radio. We should start hearing something, I think. Okay, so this is open. There we go. Sounds like more is better. There's a trimmer. I can add a little more, but it's hardly anything. No, it's not going to be enough. Well, what do we got now? What do we got happening here? Variable capacitor, when it's closed like this, is 300. This is 50. So the suggestion is to go a much larger capacitor here. Okay, I'll get a much larger capacitor there. This is 560. Should be beyond the range of this. So I'll take this off. Put on this capacitor and we'll just touch it here. Sounds louder. But if I... Oh, but we gotta be looking at the effect on the SDR. Okay, hold on, let me back up. Let's put the SDR on the screen here. Okay, so we see the tuning there, right around, still in the wrong spot, but it's there. I'm gonna decrease the capacitance. And it just goes down, down, down. At some degree, just getting less and less signal through. I think that's really what's happening there. Okay, now, I'm going to take the lead off the variable capacitor, put it back on the fixed one. Get on there. But now bypass right on the radio. Now take the big capacitor and put that on. No resonance. Where are we getting to here? So somewhere between 500 and okay, I got an idea for that. That's not enough capacitance showing up here. So one way would be to parallel in this one, which is hooked up to the oscillator back here. Hey, more tubes for Mike. Tube junction, let go, please. It's like a rectifier tube. 35Z5. Isn't that the same? No. This one has a diode. Okay, so now both these are free. I can connect them together. If I can just find something quickly to do it with. of dumb what we're going to do with this. Go down there like that. Wow, this is bad. Bad way to do it, but... Okay, two capacitors are hooked together. More capacitance is available. Start up there. Put on the signal. It's louder than it's... Let's look, see what's happening. Okay, so at this point you might say, what the heck are you doing, Jim? And what I'm doing is I'm trying to assess the value of the series capacitor with the antenna. And beyond that, I'm goofing around. Okay, so we're looking at the front end tuning. And I'm going to open this capacitor all the way. So I think the tuning may still be there, the resonance may still be there, but there's no signal available. Now we're bringing in the sweep signal, closing up the capacitor. Just gets better all the way. So now we're talking about 400, we're getting close to 500, the same as the other capacitor that I tried this with. So I'm going back to the other capacitor. Here we go. The other being the 500. So in this arrangement, we've seen no resonance with a 500 picofarad discrete capacitor. Is it because of my fingers here? No. But if I put it through the 500 tunable and get it to work, get it to what happened? She's gone. She's gone. She's gone dead. What happened there? We have lost it. We have lost it. What happened? Why does this always happen to me? Well, the whole thing has suddenly failed here. I don't get it. So I've got the signal generator output coming to here. The two connected together. Chassis continues on this wire. Oh, I got it going through the clip lead. I got it going through the capacitor rather. Yeah, I turned it down. I turned it down. Oh, I should hear it now. What's going on here? This capacitor alone. Ooh, what happened there? Something happened right in here. Let's look at the SDR again. Okay, so we're right in the spot where I could hear something. We go more capacitance. Less capacitance. There's that tuning spot. Oh. So what I did there, I'll have to show you on camera. Let me tune this capacitor again. That's less capacitance, more. So it always likes more. Okay, and this is sorry, I'm not talking while I do this quickly. More volume, no resonance. Okay, just trying different combinations of things to try to find the magic capacitance that might be in series with the source signal. It's not an antenna I'm doing this with. We should do this with an antenna. That would be a better idea. Okay, so we're going to do it with my outdoor antenna. We're going to hook this up to here. Now we've already learned that the alignment is off on this radio and the local oscillator is targeting a different spot from the front end of the radio. So that's probably the essence of the problem. I should probably warp down the local oscillator to bring it in line. It's probably where I'm going with this. But another alternative is to mess around with the two IFs. Remember, when I got this radio, the IFs were tuned way down. Way down at around 410 or something instead of 455. So 410 would make the radio target an even more incorrect frequency from the front end. I think I got that right. I feel the urge to take a break coming on here. Okay, so we're going to try the antenna. We are on the antenna. We don't know where we're tuned anymore, but we're very close to that station. Put it on the loop antenna and find the station. Okay. Radio got quieter when I did this. And we are connected through the little capacitor here. I'm going to bypass that capacitor. We'll listen a little bit more volume. It likes the capacitance. Now, we'll fool with the ground lead. Ground lead we will attach to the radio ground over here, the chassis. What's happening now? Turn it up. Who knows? That's a bit of an interesting, or different. I better take a look on the SDR here. Okay, to the SDR. Okay, you can see where the local oscillator is sitting right now. And I'm going to tune the auxiliary capacitor. See no resonance area. Okay, I'm going to take the ground off and turn the radio down. Take the ground. This is the ground going out to the antenna. Okay, I'm going to tune the capacitor. This is the auxiliary tuning capacitor. Oh, I see something happening. Seems to be a tuning effect going on down in here. But that's not where we want that to be. I don't see anything going on from the radio itself at all. Okay, I've got the little capacitor I soldered to the radio out of the circuit. Now it's in. You still don't see. Of course, I don't have the sweep going by, so it's really a question of how much noise there is, whether we can see the front end curve. You can't see it right now. Tuning, auxiliary capacitor. They're getting nowhere here at all. Getting nowhere. Okay, back to just outdoor antenna connected to the 50, actually 40 capacitor. So this would imitate the way the radio, I believe, is supposed to operate. And we get nothing on the front end. Why is that? I thought we used to. Oh, you can see it there nicely. Oh, wow. I think what's happening, there's no signals to boost under 600. So let's pick one and we'll boost it. Turn down the volume. Okay, so what I've done is I've tuned the radio until the front end is boosting this signal. This signal's frequency is 640. There happens to be a station there. 640, can we hear it? A noise signal. But that's okay. Now, we want this to be exactly 455 kilohertz above this. So that would be, you take 641, add 455 to it. Well, you pretty much get 1 million out of that, don't you? Very close to 1 million, just under 1 million. So this local oscillator should really be sitting about there right now. What the dial is showing, I can't see the dial. I'm guessing it's showing like 800 or something. The dial's saying it's here. The local oscillator is trying to do something here, and the actual front end is tuned here. So let's force the local oscillator, if I can, all the way down to this red line. Can he do it? Okay, that's using the trimmer. That's a long ways, but we will see what happens. I had the feeling it's going to go the other way. Okay, I am in. And we're now going to try to move the local oscillator. It's going the other way. So, well, this is a real problem. Okay, so I'm going to try to tighten that baby up. No, there's no way it's going to make it. We can't make it. So what are you left with? You're left with messing around with the IF frequency to compensate, but certainly not in the direction it was done in. I'd have to raise the IF frequency to match the difference between and just see what we have to raise it to. Okay, so I think I've tuned the radio now to more or less max this. And as I said before, this is about 650, so it's about 1100 where it should be, and it's up here. I can't bring it down any. So we need this range to be covered by the IF, if I could put it that way. So this would be 640, say 640, and 640, it's 1170. I can't think anymore. But the difference between those two numbers, 1171 and 640, 530. That's, I could tune the IF to that, and this radio would then be aligned. Or is there something wrong with the radio that I haven't figured it out yet? But if I were to fix it, whatever it is, these things would be closer together. And tuning the trimmer capacitor on the antenna part of the tuning capacitor doesn't have any effect on anything. Is that true? Let me double check. We've got a real nice response on the screen right now. I'm going to fool with the trimmer again. Maybe I did something wrong last time I did it. Just having some trouble getting the screwdriver in. There we go. Okay, screwdriver in. Now, move that tuning stuff. Move it. Well, it is moving, but not much. So I've reduced the capacitance by doing that. If I increase it and do it fast enough, we can see the effect. Whoops. Screwdriver fell out, of course. Okay, here we go. Come on, screwdriver. It just keeps coming out. No, it's not going anywhere. It's going a slight amount. Of course, I'm at the low end of the band where this has the least effect, I believe. Would that be right? Yeah, low end of the band, the tuning capacitor is loaded with capacitance. The trimmer's not making much difference. The high end of the band, the tuning capacitor has low capacitance, and then the trimmer has a big effect. Okay, I'm going to stop at this point and ponder the situation. Something has to be done. I would much prefer moving the local oscillator around. Okay, break time. Okay, moving the oscillator somewhere it doesn't want to go. So the oscillator coil is here, and just above it, there's on the schematic, there's a capacitor right there, 50 picofarad capacitor. I wonder about that. I do. It's sitting right there. If you can, get this here. Yeah, we do need that there. So you can see that capacitor sitting right there. Now, what if that guy has lost its capacity? I don't know. But if I watch the local oscillator frequency on the SDR, that made it go low. So, what am I doing? Am I adding capacity here? We need that to go down like this. Is it possible that this capacitor is really a major cause of a problem here? That perhaps its value is off, and perhaps it's leaky too. So I'm going to do a little research into that guy. In fact, I think we need to switch cameras and look more closely down in that area there. Well, there it is, and it's connected at the top here. What's going on at the bottom? That's why I've got this camera out to try to. The lead is it dropping through the hole there? There's a hole on the other side. You can see it looks like three wires going down there. 1, 2, 3. So one one's quite dark, like it's all cover as opposed to insulation. It's going up to one of the 2 pins. This radio's operating. Don't forget that, Jim. Okay, and what pin is it going up to? There's also a resistor right here. Where's that going? There. That's all. It's going to a pin. Also. Okay, so the wire of interest, the very black one there, is coming up to that. Okay, that's where the resistor is connected. Brown, black, orange resistor. Brown, red, black. 20K? 20K resistor, and It looks like that's coming up. And can I count them? Yeah. Terminals on the tube. No, let's switch and look at the schematic here. I'm taking a look at this camera here. So this is the capacitor I'm looking at. There's the 20K right there. Okay, let's check these out. Something going on with these two guys. Maybe it's not 20K. Maybe it's not 50 picofarads. How are we going to do that? Well, we'll give it a shot. Give it a shot. Okay, let's turn off the radio. Looking at the circuit diagram, it appears as if the capacitor this way is basically connected to nothing. Going through the 20K, coming down this way, go through this coil and find a ground. So maybe I can't read the capacitance directly, but I'm going to try. I'll use this guy here. Go on top of the capacitor, and on the bottom is this lead on the resistor. What do you say? Capacitor, 29 picofarads, but it's supposed to be 50. How can it read lower? If there was 50 in that capacitor, wouldn't this have to show at least 50? Or more? Less? Doesn't this really mean the capacitor is actually weak? Well, it justifies going the next step, which is disconnecting the capacitor one lead and measuring it. Okay, I'm probably on my way to replacing it no matter what, so we're going to just nip it off here. Okay, free. He's free. Let's try the test again. $65. Well, it's supposed to be 50. 65. I can't in my own head resolve how this capacitance might affect the resonance in here. So this is reading high. Usually that means the capacitor is leaky. That's been my experience. Let's take it out of there. Give it the full Monty test. Okay, capacitor coming out. Let's repeat this test. And we're gonna, this is not the full Monty, this is the partial Monty. The full Monty would be a voltage test across it. What do you say this time? He says. Right. It's right on the money. Well, son of a gun. Well, let's give it the leak test here. Typically, I find these capacitors to be highly reliable. I think I'm just finding more proof of that. So I'm going to put a voltage across this, and we're going to see what kind of current leaks through it. Okay, 50 volts, watching the eye. Oh, it's 250. There's nothing wrong with this capacitor at all. Nothing at all wrong with it. Ah! Unnecessary removal. I'm not going to get that back in. I have to put in another 50, a different 50. Shoot. Really? 50? Yes. 50. Huh. Could calibrate my instruments with this. That's disappointing. That is very disappointing. Now I gotta think for a minute. Maybe I should put back a bigger or a smaller one. To see where, if that doesn't shift. Yeah, like it's not part of the tank circuit here. It's up here. 50. How can I? Okay. How can I save myself here? Okay, maybe I've got a method here I can check through this. 152 picofarads on a trimmer, tightened right down. So if I were to somehow put this in the circuit, and I can adjust this and find out what it does to the local oscillator. How in the heck am I going to do this? Connecting from here to here, just around the outside. It's just a little connection here. I do a sloppy job of it though. You know, what's the value? So the idea would be to adjust this until the local oscillator gets to where I want it. We'll then measure the capacitance of this, and then that becomes the amount I got to put in. This is the scheme I'm attempting. I'm going to put a great big clip lead in here now. Don't I have a shorty? Don't I have a shorty clip lead? I do. I do have. Well, not really a shorty. It's not short. That, I'm going to bring this into contact here. Trying to involve the least amount of wire. That's a pretty crummy arrangement there. Add a little clip onto here. Okay, I gotta fetch it. Yeah. I really don't know what's going to happen here, and I don't know what I'm going to be proving. This is cranked down tight, and what did we see there? Was it 300, 250? It was a lot. So we'll start with this cranked down tight, and I think we're good to go here. Here we go. Okay, this is out. Sorry, I want that in there because we have to see the oscillator, if it's even going. Okay, I'm going to flip over to the SDR from here, and all I'll be doing is fiddling with this guy while you watch. Oh my gosh, what is wow. What's going on here? This is huge. Isn't this much larger than it was? Okay, so the local oscillator is at 11.155. So we'd want to be at 700. So this is tuned to 700 right now, the radio. The local oscillator is shooting for 700. We want to move the local oscillator down about this far, roughly. Let's see if we can get it to go down. Now, as soon as I put my fingers on this, things are going to jump around. That's my fingers. Okay, I'm going to try to... Okay, I'm ready to do the capacitor, which I cranked down so tight I can't get it loose. Look, it's coming loose. Which way is it going? It's going up. We don't want it to go up. We want it to go down. I want it to go down. You need more capacitance than this? Am I getting something wrong here? 50 picofarad. So all this wire out here? Well, this isn't, this is nowhere near what I would expect to have happen. So basically 50 picofarad, and there's too much range. 300 picofarad, and it's hardly moved. It's very unlikely too. This resistor sticking out here. Let's take a look. Well, got one. We'll use this meter here. It's in the circuit, so could be false. Oh, it thinks it's a capacitor. It thinks it's a capacitor. The schematic says it's a resistor value 20K, and I already looked at it. Red, black, orange. This is a 20K. So that last test certainly didn't actually suggest that this is open. It's really what. That's not very likely, but we will see what we get here with 20K. $20K. $23.5. Affecting the oscillator. 20K is a pretty round number. But 20K is not a standard resistor number. It could be 22. So this is a carefully selected value, likewise with this. Produce some kind of filtering thing happening here. A resistor causing a variation in the frequency? No, I don't think so. I don't know. So I'm trying to affect the resonance of this by manipulating that. I can expect this to do like a little bit of a variation. That's what I would think. But nothing grand like what I'm looking for. The local oscillator is running high. It's running high. Bring it lower by reducing, or by increasing the amount of capacitance here. You increase the amount of capacitance here. Somehow stick a 50 back in there and just forget this. Try to increase the capacity here. How could it be reduced? Something's happened to the coil. Some kind of life degradation, because I see a lot of these radios seem to be off in a way that can't be corrected. So it could be the coil has gone off for some reason I don't fathom. I mean, these things are mechanical things, right? They're fixed. Why would they be any different today than they were the day they were made? Well, there could be an answer to that question. Especially with a capacitor, of course. So I want to dump more capacitance into the oscillator. Well, why don't I take that trimmer and add it to the oscillator side? And now I have to resolve this situation here. Shoot. Oh, it's late in the day. I think I'm going to call it quits here. Next step will be to restore this back. Not worry about the resistor. Attempt to augment the capacitance in the tuning capacitor to move the local oscillator to where it really needs to be. Or I'll think of something else that's causing this to be out of whack so badly. Okay, well, thanks for watching today. and just carry on tomorrow. See ya.